In how many ways can a girl and a boy be selected from a group of 15 boys and 8 girls? Option A 15 into 8, option B 15 plus 8, option C 23P2, option D 23C2. Therefore, the solution is required number of ways is equal to 15C1 into 8C1, that is equal to 15 into 8. Therefore, option A is correct. If 15C3R is equal to 15CR plus 3, then the value of R is option A 2, option B 4, option C 5, option D 8. Therefore, the solution is 15C3R is equal to 15CR plus 3. Therefore, that is equal to 15 minus 3R is equal to 15CR plus 3. That is equal to 15 minus 3R equal to R plus 3. That is equal to R is equal to 3. Therefore, option A is the correct answer. 47C4 plus 5 submission R plus 1, 52 minus R C3 is equal to option A 47C6, option B 52C5, option C 52C4, option D none of these. Therefore, the solution is 51C3 plus 50C3 plus 49C3 plus 48C3 plus 47C3 plus 47C4. That is equal to 51C3 plus 50C3 plus 49C3 plus 48C3 plus 48C4. Since NCR plus NCR minus 1 is equal to N plus 1 CR, that is equal to 51C3 plus 50C3 plus 49C3 plus 49C4. That is equal to 51C3 plus 50C3 plus 50C4 equal to 51C3 plus 51C4 is equal to 52C4. Option C is correct. If 2NC3 ratio NC2 is equal to 44 ratio 3, then for which of the following values of R the value of NCR will be 15? Option A R is equal to 3, option B R is equal to 4, option C R is equal to 6, option D R is equal to 5. Therefore, the solution is 2n factorial upon 2n minus 3 factorial into 3 factorial into 2 factorial into n minus 2 factorial upon n factorial is equal to 44 upon 3. Therefore, 2n minus 1, 2n minus 2 upon 3n n minus 1 is equal to 44 upon 3. That is equal to 2n minus 1 is equal to 44 is equal to 2n is equal to 12, n is equal to 6. Now 6CR is equal to 15. Therefore, 6CR is equal to 6C2 or 6C4. Therefore, R is equal to 2, 4. Therefore, option B is correct. If 18C15 plus 2 bracket 18C16 plus 17C16 plus 1 is equal to NC3. Then n is equal to option A 19, option B 20, option C 18, option D 24. Therefore the solution is 18C15 plus 18C16 plus 18C16 plus 17C16 plus 17C17 is equal to NC3. Since NCN is equal to 1, that is equal to 18 plus 1 C16 plus 18C16 plus 17 plus 1 C17 is equal to NC3. Since NCR minus 1 plus NCR is equal to N plus 1 CR, that is equal to 19C16 plus 18C16 plus 18C17 is equal to NC3. It is equal to 19C16 plus 18 plus 1 C16 is equal to NC3 is equal to 19C16 plus 19C17 is equal to NC3. It is equal to 19 plus 1 C17 is equal to NC3 equal to 20C3 is equal to NC3. Therefore N is equal to 20. Therefore option B is correct. If NCR minus 1 is equal to 36, NC3 is equal to 84 and NCR plus 1 is equal to 126, then the value of R is option A 1, option B 2, option C 3, option D none of these. Therefore the solution is here NCR minus 1 upon NCR is equal to 36 upon 84 and NCR upon NCR plus 1 is equal to 84 upon 126, that is equal to 3n minus 10R is equal to minus 3 and 4n minus 10R is equal to 6. On solving we get n is equal to 9 and R is equal to 3. Therefore option C is correct. If NC12 is equal to NC6, then NC2 is equal to option A 72, option B 153, option C 306, option D 2556. Therefore the solution is given NC12 is equal to NC6. Therefore 12 plus 6 is equal to N, that is N is equal to 18. Therefore 18C2 is equal to 18 into 17 upon 2, that is equal to 9 into 17, that is equal to 153. Therefore option B is correct. From 6 different novels and 3 different dictionaries, 4 novels and 1 dictionary are to be selected and arranged in a row on a shelf so that the dictionary is always in the middle. Then the number of such arrangement is option A less than 500, option B at least 500 but less than 750, option C at least 750 but less than 1000, option D at least 1000. Therefore the solution is 6C4 into 3C1 into 4 factorial, that is equal to 6 into 5 upon 1 into 2 into 3 into 24 is equal to 1080. Therefore option D is correct. If 189C35 plus 189CX is equal to 190CX, then X is equal to option A 34, option B 35, option C 36, option D 37. Therefore the solution is 189C35 plus 189CX is equal to 190CX. Since NCR plus NCR minus 1 is equal to N plus 1 CR. Therefore, X is equal to 35 plus 1 is equal to 36. Therefore, option C is correct. If A is equal to NC2, then AC2 is equal to option A N plus 1 C4, option B M minus 1 C4, option C 3 into M plus 2 C4, option D 3 into M plus 1 C4. Therefore, solution is A is equal to MC2, that is A is equal to M minus 1 upon 2. Therefore, AC2 is equal to M minus 1 upon 2 C2 is equal to half M minus 1 upon 2 N minus 1 upon 2 minus 1, that is equal to 1 upon 8 M minus 1 M minus 2 M plus 1 is equal to 1 upon 8 M plus 1 M minus 1 M minus 2 is equal to 3 into M plus 1 C4. Therefore, option D is correct. In a mathematics paper, there are 3 sections containing 4, 5 and 6 questions respectively. From each section, 3 questions are to be answered. In how many ways can the selection of questions be made? Option A 34, option B 800, option C 1600, option D 9600. Therefore the solution is, mathematics paper has 3 sections. A 4 questions, B 5 questions, C 6 questions. Each section we have to select 3 questions. Therefore, total number of ways is equal to 4C3 into 5C3 into 6C3, that is equal to 800. Therefore, option B is correct. If NC3 plus NC4 is greater than N plus 1 C3, then option A N greater than 6, option B N greater than 7, option C N smaller than 6, option D none of these. Therefore, the solution is NC3 plus NC4 is greater than N plus 1 C3, that is equal to N plus 1 C4 plus N plus 1 C3. Since NCR plus NCR plus 1 is equal to N plus 1 CR plus 1, that is equal to N plus 1 C4 upon N plus 1 C3 is greater than 1 is equal to N minus 2 upon 4 is greater than 1 is equal to N is greater than 6. Option A is correct. The number of ways in which 4 letters of the word mathematics can be arranged is given by option A 136, option B 192, option C 1680, option D 2454. Therefore, the solution is, word mathematics has 2M, 2T, 2A, HEICS. Therefore, 4 letters can be chosen in the following ways. Case 1, 2 alike of one kind and 2 alike of second kind, that is 3C2. Therefore, number of words is equal to 3C2 into 4 factorial upon 2 factorial into 2 factorial, that is equal to 18. Case 2, two alike of one kind and two different, that is 3c1 into 7c2, that is equal to number of words is equal to 3c1 into 7c2 into 4 factorial upon 2 factorial, that is equal to 756. Case 3, all are different, that is equal to 8c4 is equal to number of words is equal to 8c4 into 4 factorial, that is equal to 1680. Hence total number of words is equal to 2454. Therefore option D is correct. If n plus 1 c3 is equal to 2 nc2, then n is equal to option A 3, option B 4, option C 5, option D 6. Therefore the solution is n plus 1 c3 is equal to 2 nc2 is equal to n plus 1 factorial upon 3 factorial n minus 2 factorial is equal to 2 into n factorial upon 2 factorial n minus 2 factorial, that is equal to n plus 1 upon 3 into 2 factorial, that is equal to 2 upon 2 factorial is equal to n plus 1 equal to 6, n is equal to 5. Therefore option C is correct. n minus r plus n r plus 1 whenever 0 smaller than equal to r smaller than equal to n minus 1 is equal to option A n r minus 1, option B n r, option C n r plus 1, option D n plus 1 r plus 1. Therefore the solution is n minus r plus n r plus 1 is equal to nc n minus r plus nc n plus 1, that is equal to ncr plus ncr plus 1 is equal to n plus 1 cr plus 1, that is equal to n plus 1 r plus 1. Therefore option D is correct. The least value of natural number n satisfying c n comma 5 plus c n comma 6 is greater than c n plus 1 comma 5 is option A 11, option B 10, option C 12, option D 13. Therefore the solution is nc5 plus nc6 is greater than n plus 1 c5 is greater than n plus 1 c5, that is equal to nc5 is equal to n plus 1 c6 is greater than n plus 1 c5, that is equal to n plus 1 factorial upon 6 factorial n minus 5 factorial into 5 factorial n minus 4 factorial upon n plus 1 factorial is greater than 1, that is equal to n minus 4 upon 6 greater than 1, that is equal to n minus 4 greater than 6 equal to n greater than 10. Hence according to the options, n is equal to 11. Therefore option A is correct. The value of n minus 1 summation r is equal to 0. ncr upon ncr plus ncr plus 1 equals option A n plus 1, option B n upon 2, option C n plus 2, option D none of these. Therefore the solution is n minus 1 submission r is equal to 0 ncr upon ncr plus ncr plus 1, that is equal to n minus 1 submission r is equal to 0 1 upon 1 plus ncr plus 1 upon ncr, that is equal to n minus 1 submission r is equal to 0 1 upon 1 plus n minus r upon r plus 1 is equal to n minus 1 summation r is equal to 0 r plus 1 upon n plus 1 is equal to 1 upon n plus 1 summation r is equal to 0 r plus 1 is equal to 1 upon n plus 1 1 plus 2 plus n is equal to n by 2. Therefore option B is correct. In an election, the number of candidates is one greater than the persons to be elected. If a voter can vote in 254 ways, then the number of candidates is option A 7, option B 10, option C 8, option D 6. Therefore the solution is, let there are n candidates. Therefore NCR plus NC2 plus NC n minus 1 is equal to 254. That is equal to 2 raised to n minus 2 is equal to 254. That is equal to 2 raised to n is equal to 2 raised to 8 is equal to n is equal to 8. Therefore option C is correct. A student is to answer 10 out of 13 questions in an examination such that he must choose at least 4 from the first 5 questions. The number of choices available to him is option A 140, option B 196, option C 230, option D 346. Therefore the solution is, as for given question, two cases are possible: selecting 4 out of first 5 questions and 6 out of remaining 8 questions, that is equal to 5C4 into 8C6 is equal to 140 choices. Case 2, selecting 5 out of first 5 questions and 5 out of remaining 8 questions. Therefore that is equal to 5C5 into 8C5 is equal to 56 choices. Therefore total number of choices is equal to 140 plus 56 is equal to 196. Therefore option B is correct. The number of ways of dividing 52 cards amongst 4 players equally are option A 52 factorial upon 13 factorial raised to 4, option B 52 factorial upon 13 factorial square into 4 factorial, option C 52 factorial upon 12 factorial raised to 4 into 4 factorial, option D none of these. Therefore solution is, required number of ways is equal to 52C13 into 39C13 into 26C13 into 13C13, that is equal to 52 factorial upon 39 factorial into 13 factorial into 39 factorial upon 26 factorial into 13 factorial into 26 factorial upon 13 factorial into 13 factorial into 13 factorial upon 13 factorial, that is equal to 52 factorial upon 13 factorial raised to 4. Therefore option A is correct. In the 13 cricket players, 4 are bowlers, then how many ways can form a cricket team of 11 players in which at least 2 bowlers included? Option A 55, option B 72, option C 78, option D none of these. The number of ways can be given as follows: 2 bowlers and 9 other players is equal to 4C2 into 9C9. 3 bowlers and 8 other players is equal to 4C3 into 9C8. 4 bowlers and 7 other players is equal to 4C4 into 9C7. Hence, required number of ways is equal to 6 into 1 plus 4 into 9 plus 1 into 36, that is equal to 78. Therefore, option C is correct. The number of groups that can be made from 5 different green balls, 4 different blue balls and 3 different red balls, if at least one green and one blue ball is to be included. Option A 3700, option B 3720, option C 4340, option D none of these. Therefore, the solution is at least one green ball can be selected out of 5 green balls in 2 raised to 5 minus 1, that is in 31 ways. Similarly, at least one blue ball can be selected from 4 blue balls in 2 raised to 4 minus 1 equal to 15 ways. And at least one red or not red can be selected in 2 raised to 3 is equal to 8 ways. Hence, the required number of ways is equal to 31 into 15 into 8, that is equal to 3720. Therefore, option B is correct. In how many ways can 6 persons be selected from 4 officers and 8 constables if at least one officer is to be included? Option A 224, option B 672, option C 896, option D none of these. Therefore, the solution is required number of ways is equal to 4C1 into 8C5 plus 4C2 into 8C4 plus 4C3 into 8C3 plus 4C4 into 8C2, that is equal to 4 into 56 plus 6 into 70 plus 4 into 56 plus 1 into 28 is equal to 896. Therefore, option C is correct. Out of 6 boys and 4 girls, a group of 7 is to be formed. In how many ways can this be done if the group is to have a majority of boys? Option A 120, option B 90, option C 100, option D 80. Therefore, the solution is 1 girl and 6 boys is equal to 4C1 into 6C6 is equal to 4. 2 girls and 5 boys is equal to 4C2 into 6C5 is equal to 36. 3 girls and 4 boys is equal to 4C3 into 6C4 is equal to 60. Hence, total ways is equal to 60 plus 36 plus 4 is equal to 100. Therefore, option C is correct. The number of ways in which 10 persons can go in 2 boats so that there may be 5 on each boat, supposing that 2 particular persons will not go in the same boat, is option A half 10C5, option B 2 8C4, option C half 8C5, option D none of these. Therefore, the solution is First, omit 2 particular persons, remaining 8 persons may be 4 in each board. This can be done in 8C 4 ways. The 2 particular persons may be placed in 2 ways, one in each board. Therefore, total number of ways are equal to 2 into 8C4. Therefore, option B is correct. The total number of natural numbers of 6 digits that can be made with digits 1, 2, 3, 4 if all digits are to appear in the same number at least once is option A 1560, option B 840, option C 1080, option D 480. Therefore, the solution is there can be two types of numbers. First case, any one of the digits 1, 2, 3, 4 repeats thrice and the remaining digits only once. That is of the type 1, 2, 3, 4, 4, 4. Case 2. Any two of the digits 1, 2, 3, 4 repeat twice and the remaining two only once. That is of the type 1, 2, 3, 3, 4, 4, etc. Now, number of numbers of type 1 is equal to 6 factorial upon 3 factorial into 4C1, that is equal to 480. Number of numbers of type 2 is equal to 6 factorial upon 2 factorial into 2 factorial into 4C2, that is equal to 1080. Therefore, required number of numbers is equal to 480 plus 1080, that is equal to 1560. Therefore, option A is correct. All possible two factors products are formed from numbers 1, 2, 3, 4 till 200. The number of factors out of the total obtained which are multiple of 5 is option A 5040, option B 7180, option C 150, option D none of these. Therefore, solution is the total number of two factor products is equal to 200C2. The number of numbers from 1 to 200 which are not multiples of 5 is 160. Therefore, total number of two factor products which are not multiple of 5 is 160C2. Hence, the required number of factors is equal to 200C2 minus 160C2, that is equal to 7180. Therefore, option B is correct. The total number of ways of selecting 6 coins out of 20 1 rupee coins, 10 50 paise coins and 7 25 paise coins is option A 28, option B 56, option C 37C6, option D none of these. Therefore, the solution is since the total number of selections of R things from things where each thing can be repeated as many times as one can is n plus 1 n plus r minus 1 cr. Therefore, the required number of ways is equal to 3 plus 6 minus 1 C6 is equal to 28. Therefore, option A is correct. The number of diagonals of a polygon of m sides is option A 1 upon 2 factorial m minus 5, option B 1 upon 2 m minus 1, option C m upon 2 factorial m minus 3, option D 1 upon 2 factorial m minus 2. Therefore the solution is, as we know, polygon has two diagonals, therefore required number of diagonals is equal to mc2 minus m, that is equal to m minus 1 upon 2 factorial minus m, that is equal to m upon 2 factorial m minus 3. Therefore option C is correct. Let Tn denote the number of triangles which can be formed using the vertices of a regular polygon of n sides. If Tn plus 1 minus Tn is equal to 21, then n is equal to option A 5, option B 7, option C 6, option D 4. Therefore the solution is clearly NC3 is equal to Tn. So n plus 1 C3 minus NC3 is equal to 21, that is equal to NC3 plus NC2 minus NC3 equal to 21. Therefore NC2 is equal to 21, or n minus 1 is equal to 42, that is equal to 7.6. Therefore n is equal to 7. Therefore option B is correct.